All right. All right. I'm going to practice a little bit. I want to get better at doing circuits. So let's see. Problem one is a series warm-up, all right? So we have the V supply, which is, all right, this is 330 ohms. This is 650 ohms. All right. And what we're trying to do is find the R total, which is the RT, which is just R1 plus R2. So then you would put, obviously just put RT equals 330 ohms plus 650 ohms, which is just turns into, damn my tongue, 9, here, let me switch. That just turns into 980 ohms. All right. That's it for number one. I'm pretty sure doing this on ChatGPT. All right. Now, what's the flow of the current? What's the current going through the flow? Oh, okay. So now that we have the resistance, we're trying to figure out the I. So we know Ohm's law is V equals IR. So in order to get the I, we have to do V over R equals I. So then that's just going to be 10, because we know the V is 10 volts. Looks like a P. Over 980. And then let me just get a calculator. All right. And then we just do 10 divided by 980. All right. And then I got the total of 0.0102 ohms, or 2 milliamps, or 2 amps, I mean. All right. Which then we could just turn into 1, 2, 10.2 milliamps. At least I believe so. So then, let me try that. 10.2 milliamps. You have to remember for R it's ohms, for I it's amps, for P it's watts, for yeah. Okay. I was correct then. It is 10.2 milliamps. All right. Now let's find the voltage drop between each resistor. So now we're going to be finding the VR1 and VR2. All right. All right, doesn't matter. All right, so now that so for let me see the formula again. Oh, it's just again for VR1, it's just V equals IR. All right. So we could just do, now that we know the I, so VR1 is equal to 10.2 times R1, which is 330. All right. So we just do 10.2 times 330, which is 3366 milliwatts. I'm guessing, no, but that seems kind of high about the same time. So you would probably do the original, which is this instead of this. So you would do 0.0102 times 330, which is, oh, it's just 3.366. So it is technically the same exact thing, except the period. That's really what it was. I see. And then we just turn that to watts. At least I think so. Let me double check. Well, actually, let's solve both of them. All right. So now we have VR1, R2, which is 10.2 times 650. All right. So then we just do 10.2 times 650. So I believe it would be 6.630. So, oh, it's gonna be V actually. Yeah, this is a volt, so it's gonna be a V. All right. So now let me just type in my answers and make sure we are correct. All right. 3.366 V2 equal 6.630. And then volts at the ends. All right. Let me check. Am I correct? Please tell me. Oh, was it 680? Wow. Now we're going to be doing power. All right. So P of t is the total power, which is going to be it's either I squared or what was it? Or it was either I squared R or VI. I think I'm going to go with VI instead, just because I know that better. All right. So we know the V is 10 times 10.2, which may be 102. So that's going to go 102. This could be watts or milliwatts. Let me just try the other way. 0.0102 times 10. Oh yeah, and it's going to be watts, but we're actually going to make that milliwatts. Oh, that's the total power. Yeah, so I mean, I was right. So to do P1, which is just only the VR1 basically, it's going to be, we have to do the IR squared. So let me get my handy dandy calculator and put 0.0102 times, whoop, actually, where's the square? Times 330, which is going to be that's going to be, so for P1, that's going to be 0.034, which is going to be 334.3 milliwatts. This is going to be watts normal. And for P2, god damn. Holy moly. Now for P2, it's going to be 0.0676, which is just going to be turning into 6767. All right. Damn. All right. So for P1 equals will equal 0.0676. I believe so, yeah. 67. All right. And let me add them up. All right. So now you 34.3 plus 67.6, which is 101.9, which is, if we just round it up, it's 102, which was my original wattage for P total. All we have this done. Yeah, let's have we have time for one more. All right, let me take a picture. All right, and then let's erase everything. My hard work is gone. All right. All right, so our V supply, our VS. All right, actually, let me restart that. So here's our circuit, plus, minus, which is going to be, what was it? 12 volts. All right. And then this is the, all right. This is R1, this is R2, or this is R3, R2, R1, VR1, VR2, VR3, and then this is I2, this is I1, this is I3. All right. This is our parallel circuit. So we know our VS is going to be 12 volts. Our resistor 1, resistor 2, resistor 3, our I1, I2, I3, and then we have VR1. All right. So now we can check our resistor 1 is 1K. So 2, 3K. All right. 2K. Why did I do that? 3K. All right. So first we're gonna find the resistance using adding up all these. So what we could do is to find the R total, which is like that. But honestly, I hate that. I really hate this, honestly. I don't know how to do it for some reason. So to do this, it would be 1 over 1,000 plus 1 over 2,000 plus 1 over, 1 over 3,000, which is 0.00183. So that's going to be 18.3 or 183 ohms. Fuck. Oh, and then, okay, so that was wrong. All right. And then we turn into 1 over that. Which is just that. All right, so then this is our ohms. So now we know that the R total is equal to 546.4 ohms. We're going to find the current, and current is the same throughout the whole circuit. All right. So then all right. So in order to find I1, we got to do V over R. So we do, or R1 and V1 just in case, or VS. All right. So now we do 12 over 1,000. 12 divided by 1,000, which is just equal to 0.012. Which just turns into 12 milliamps. So then we know I is 12 milliamps. Now we can do I1, I2, 3, whatever. All right. So since we know that the V stays the same, for the rest it should be the same. All right. Yeah. This is what I mixed up before. I did this, but then I put the resistors like two resistors in the bottom and the top. It's a huge mess. All right. So now we just do 12 over 2K, 12 over 3K, which is just 0.006 0.004. These are all amps. Then we turn them into milliamps. So it's going to be 6 milliamps. Wait, what the fuck? 6 milliamps. 4 milliamps. So 6 MA, 4 MA. Oh, okay. Next, we're going to do I of t. So, which is just I total. So, it's just going to be 12 plus 6 plus 4, which is 22 milliamps. that's just IT is equal to I1 plus I2 plus I3. Okay. So I could also just do the entire thing instead of doing this. I could also just do for I of t, I could also do voltage supply over R total as well, which, let me check, 12 divided by 546.40.4, which is just 21.96, which we'll just round it up and just make it 22. All right. So now we could just then we do the VR stuff, all right? Which we already kind of did already. We could just do all right. So to find the VR1, we have to do I times I1 times R1. So our I1 is 12 point 0.012 times 1000, which is just 12 volts. Yeah, what? Hold on. So I guess it's just 12 volts. And then we do, wait, yeah. And what's I2, which is 6 times 2000. So VR2, which is just I2 times R2, which is just 12 volts again. It's just 12 volts all over again. It's just all 12 volts. That's definitely kind of weird, but Oh, now then the power. All right. So we know that everything is 12. What's the P? What's the P? Holy schmoly. What's the P of T? Which is just I squared 2 times R total. So our I total squared is 22 squared times 546.4. Oh, which is just 26.44. Let's see. Oh, okay. So I was right. Okay. So 26.44 MW. No, wait a second. I forgot. Wait, is there? So then we do 26.4 times 12. It's 316 times 12 volts, which is just equal to 316.8 milliwatts. All right.